Today our topic will be on electric current. At the end of this section, you should be able to define the term current and state its SI unit. Differentiate between conventional current and electron flow. An electric current is formed by moving charges. It is a measure of the rate of flow of electric charge through a given cross-section of a conductor. Current equals charge divided by time.
Scientists believed that electric current was caused by the movement of positive charges. Although this idea was proven wrong, the idea is still useful. This movement of positive charges is called conventional current. We make use of an ammeter to measure current. The ammeter should be connected in series to the circuit. Some common components and their symbols are shown here. The break in the circuit shown is caused by the open switch. The breaks in the circuit can also occur due to loose connections and missing or broken wires. In an open circuit, no electric current flows through the circuit. Hence, the ammeter shows no reading. Here, this is a case of short circuit where the current bypassed the light bulb. Next, we will look at electromotive force and potential difference. At the end of this section, you should be able to define EMF and potential difference PD. State the SI unit of EMF and PD. And lastly, calculate the EMF when a few sources are arranged in series. Note that the real electron flow is opposite to the conventional current flow. The water pump is analogous to the battery. The pipes are analogous to the wires. Without the water pump, the water in the pipes will not circulate / flow around the pipe. The pump provides the energy to move the water. In the same way, without a battery cell, the electrons in a wire will not flow. The battery cell provides the energy to move the electrons. The EMF is defined as the work done by the source in driving a unit charge around a complete circuit. The resultant EMF of the dry cells in the series arrangement is 1, 5V plus 1. 5V equals sine 3. 0V, while the resultant EMF of the dry cells in the parallel arrangement is 1, 5V. The potential difference, PD, between 2 points in an electric circuit is defined as the amount of electrical energy converted to other forms of energy when one unit of charge passes between the 2 points. Highlight to students that while the ammeter, instrument used to measure current, is connected to the circuit in series, the voltmeter is connected in parallel to the component. Help students grasp the difference between EMF and PD by highlighting to them that EMF is associated with the source while PD is associated with 2 points in the circuit. Note that the ammeter can be placed in various positions and still be in series with the bulb. The wire connections of the voltmeter can be at the circuit corners, etc. Fixed resistors have fixed resistances, whereas variable resistors can be adjusted to give a range of resistances. An example of a physical condition that needs to remain constant is temperature. Use Table 17. 2 in the textbook to further elaborate on non-ohmic conductors. The IV graphs of a filament lamp top and a semiconductor diode bottom are as shown on this slide. Tell students that as current increases, there is a tendency for the components to generate more heat, and hence result in an increase in the component's temperature. Filament lamp. The resistance of a lamp's filament increases as the temperature of the filament increases. That is, resistance is not constant. It increases with increasing current. Semiconductor diode. This device only allows current to flow in one direction. Using the second graph, show students that when P D is applied in the reverse direction, almost no current flows through this component. At the end of this section, you should be able to apply the relationship of the proportionality of resistance to the length and cross-sectional area of a wire to solve problems. Increasing the length of the conductor increases its resistance, whereas increasing the cross-sectional area of the conductor decreases its resistance. Resistivity is a property of the material used to make the conductor. Since copper has low resistivity, it has a low resistance. This means that current can flow through copper easily. Most of the wires used to conduct electricity are made of copper. Why is silver not used in place of copper since it has an even lower resistivity? Answer: silver is much more expensive as compared to copper.